Hey, welcome back to Caribou Data Science channel. I'm starting to continue to work through this manual with a clone of the HP42s calculator. The calculator is available on Windows, probably Linux, and on your on probably on your phone. This is my Pixel 4XL or 2XL running the HP the free. It's called Free42 clone. That's a clone of the HP42s calculator. Okay, and here it is on my Windows desktop, a Windows 10 desktop. So I'm up to section 2.9, getting used to some of the keys of the keyboard. So let's just go and read through this a little bit and see exactly what's going on. Let's discuss some of the basic keys of the calculator. We will start from the upper left-hand corner, left-hand side. The whatever it is, this sign plus pound and sign. These are statistical functions we will discuss later. So he's talking about this and this. Okay? L/X and /X and Y over X. The 1X key just calculates the inverse of the number which is in register X. Okay, so we look up here. 1X and ZX. 1X and YX. Okay? Switch between the two using the orange key. The 1X key just calculates the inverse of the number, which is in register X. Orange key YX is the potential function. To calculate 5 cubed equals 5 times 5 times 5, we enter 5. Let's clear everything out then. Oh, look at now we're back to the two registers. Okay. To calculate 5 cubed equals 5 times 5 times 5, we do 5, enter, right? 3 orange cube. That gives us 125. Okay, good. Okay. The square root of X key and the X squared, right? Okay. These functions just calculate the square root and the square of number in X. When studying complex numbers, we see that unlike HP33s, the HP42s, the number in square root can be negative. Log and 10x. These functions calculate the base 10 logarithmic and its inverse. Log and inverse log. The ln and the ex, I was wondering what the ln was. Ln, these functions calculate the natural base e 2.71828, etc. Logarithm and its inverse. If we want logarithm in another base, we can use the function, we can use the relation log z, y equals log minus z, minus zy, divided by log zx, where z is any other base. If we take z equals e equals 2.71828, then we have log example, calculate log 28. Answer. Eight, 2, oh wait, if I could count, I'd be much better off. 8, ln, 2, ln, enter. Okay, does that slash mean? Let's try this. 8, log n, 2, log n. Now is that a divide? Okay, gives us 3. Okay, very good. Because that was so the divide was the function. XEQ and orange GTO. These are related to programming, and we will discuss them later. XEQ will also be discussed in the alpha menu part. The STO and a complex. Okay, these are related to memories and complex numbers. We'll discuss them later. Rcl and percent. Rcl is related to memories and will be discussed later. The percent is the percent function. To calculate 10% of 300, we do enter 10 orange. Calculate 300 plus 10%. You do 300, enter. Enter. 10%. percent plus. Hang on. Okay. Let's try this also on the calculator here, shall we? So, 300. Okay, good. So we enter 3, enter. Gives us 30. Okay. Note that 300 remains in line Y. So if you want to calculate 300 plus 10%, you do 300, enter, enter, 330. Okay. Okay, makes sense. So it's going to be 300, enter, 10, plus. Okay, very good. Now, we've already discussed these. The first rolls down the stack and the other returns pi. Sine and a sine. Is a sign of the times? A sign of the times. Sorry. So those two are right there. These are the sine trigonomic functions and inverse. The angle type is set up as said before in the Moans menu. The default is degrees. A sine is inverse, usually called r, and sometimes sine minus 1. Not to be confused with the consonant, consonant, which is 1 divided by sine, or 1 over sine. It is important to remember that a sine is not a real function, since there's no singular result. For example, sine 135 degrees equals sine 45 degrees equals square root of 2 divided by 2. But the calculator gives you a sine. HP42s will give a complex number if the input of the arc sines is bigger than 1 or smaller than negative 1. Okay. Cos and acos. These are the cosine trigonometric functions and inverse. Tan and atan. These are the tangent trigonometric functions and inverse. Now, all numbers can have a result for tangent. For example, tan 90 degrees gives infinity. The HP42s gives a big number instead. Okay. Enter an orange alpha. Got it. Enter alpha. The enter key does not need any comment. The alpha key is the alphanumeric menu used to enter letters instead of numbers. When you press orange key alpha, what appears is this. Oh, does it really? I'll be the judge of that. Oh, there it is. Nice. Hmm. Okay. Then just pick the letter you want. But above, you can also see the symbol. This symbol means the menu has more than one line. You can access the other lines by pressing up and down. Okay. In this case, there is just one more line with the, if you press among all calculators, I know this is in my opinion the best way to enter letters. The main alpha menu also has the other lines has the following submenus. Okay, brackets, arrow keys, left to right, math. So it does. Well, yes, let's just see if this is really true. All right. Okay. Much more than one will be ever be, much one will ever be needed. If you are inside a submenu and want to go back to the main menu, press exit. Okay. Why is the alpha menu useful? Of course, it is useful to label programs and data in memory, but it's also useful to enter commands using the exeq key. For example, exeq sign is the same as pressing sign. The quotes are called automatically when pressing alpha. And the enter exeq SINH calculates the hyperbolic sign, while exeq off turns the calculator off. Huh. Finally, we must say that the alpha key is not always needed. In some cases, like exeq and GTO, we will see later, a simple enter will do. Entering alphabetic text is much easier with the Free42. Free42 allows you to just type on the native keyboard when alpha menu has been activated. Hmm. Okay, the plus minus, it just changes the sign of the numbers. The E and disp, we've already talked about the disp menu. The E is the character meaning the power of 10 in scientific notation. For example, to enter 5.2x 10 to the 22nd power, we do 2 E 22. Let's try this again then. Enter 5.2 E22. Enter. Okay. Left arrow and clear. Okay. And clear. As we said above, the left arrow clears line X. So it does. Okay. And if you're entering a number, you can delete the last character. We already talked about a little about clear menu, and we'll discuss it again later. Up and down, SST, ESST. As we said before, we use this chain to change the line in a multi-line menu. We will also see the orange BST and the orange key in ESST later. The keys from 1 to 9 obviously have obvious functions. The keys from 0 to 9 have obvious functions. The period sign and the show. The period is just a decimal point, and the pound show is used to show a number for an instant with all precision. For example, if you have a pi in the first line and you are using the display in fixed 4, so if we have a pi, so it does. Okay, let's begin with, chapter 3. This is entitled Memory. Now we're getting a little more serious here, I have a feeling. The real HP42s has about 7,200 bytes of memory, while the Free42 can have much more depending on the available memory in the computer/handheld. In fact, 72 bytes is a lot of memory for the HP42s. A program of 10 lines uses about 15 bytes of memory. This means that while in some other models, like the HP20s, you would be able to program just 99 lines. With the 42s, you would be able to create programs with thousands of lines. Holy smoke. Gee, and I got 16 gigabytes of memory on my computer here. All right. The available memory is shared with everything, including the program, variables, etc. Let's start from the basic. First of all, let's come up here. Let's clear everything. There. Okay. Let's start from the basic. To store a number, which is in register X of the stack, we use a store function. Okay. The HP42s has by default 25 positions in the memory from R00 to R24. The above to store the number pi in R10, just do the following. Okay, let's see what happens here. To store a number in register X, to store the number pi in R10, just go to the just do the following. Okay, so we're going to do let's do this. Let's clear the list. So if we want to store pi in 10, we do pi, this, store, size error. Let's do this. Let's say let's do this. Let's do 1 store. Why am I getting a size error? Try this over here. No, I do get the same thing, didn't I? Let's try this again now. One store size error. If you want to make an operation, you can use store plus, store minus, store divide. Any of these operations can be entered by pressing the store key followed by the operation key, followed by a register number. For example, 6 store minus So as you can see, we are getting a size problem here. If 25 positions in the memory is not enough for you, you can change the number by using the size function, which is in the second line of the modes menu. For example, although it is possible, I suggest you should not use more than 100 positions. These positions are stored in a normal matrix called regs. We, the poor owners of the HP43s, for example, just have 26 memories from A to Z, positions from A to Z. But this kind of memory position only accepts real numbers. What about if you want to store either other things, matrices, complex numbers, or even other real numbers? To do this in the HP42s as an arbitrary number of positions, limited only by the memory available, which uses letters to label the positions instead of numbers. We had stored the pi number in R10, but we can create a variable called, for example, pi to store it in. To do so, we just do a pound. Let's do a clear of the thing here. There we go. So let's just do this. Pound, enter. Someone took my store again. Store. HIJKLMN. P. That's interesting. And enter. Actually, it's not just pi you can type, but NOPQPFGHAI. But we wrote that for simplicity. Now to get the number back, it's just I had recall P. Enter. Interesting. Maybe that's what this problem with the size was. Huh. No, because did that set the number of spaces? Okay, anyway. Actually, okay. More generally, the store and recall functions automatically bring up a menu of previously defined variables. Oh, nice. So let's do this again. Recall. Huh. That's interesting. All right. If there are more than one, will fit on the screen. You can also use store plus, store minus, store times, store divide, even in this case, since the types of the things you operate on are the same. We can deal with the four registers of the stack as we deal with memory positions. In this case, the lines of the stack are called STX, STX, STY, STZ, and STT respectively. To access this, we press period before the name of the register. For example, Let's do a clear first. For example, 5 store period XTX puts 5 in the X stack. Yes, it does. The submenu that displayed when you press star actually has 2 other items, STL and IND. STL refers to the last X register, and IND is used for indirect perimeters. As the content of the stack can change easily, I don't think STO is a good thing, but I cannot say the same of Rcl, which may be very useful to get the content especially of registers Z and T. You can also use STO and Rcl with the plus minus X and plus and divide and period to work with the content of the registers of the stack. For example, 5 plus this is divided by, let's do this then, shall we? 5 store divide by period STZ divide register Z by 5. We can use indirect parameters by passing period IND when using store recall or any other calculator function that happens to allow indirect parameters. With indirect addressing, we can specify a location where the actual parameter is stored rather than the parameter itself. That location could be a named variable, one of the number the number of one of the stored registers, or a stack register. For example, to assign 125 to the register specified in the variable ABC. Let's clear everything. So 10 store at 10 store ABC sets ABC to 10. 125 store period IND ABC stores 125 and the register pointed to indirectly by ABC. Okay, so let's say 125 store period on the wonder IND enter recall $125. Okay, I think I'll conclude this. This concludes section or chapter 3.0. We'll pick up next time with section 3.1, the catalog menu. Hey, thanks so much for spending a few moments of your time for this evening. I have a link in the description below where you can download the Free42 clone as well as the manuals. Thanks so much. We'll catch you later on.